Hey guys, welcome to Heart Academy again. I think this is actually Heart Academy number 7. And in this episode, I'm going to review the homework for January 5th. And I'm going to show you how to do several of these problems so you do not have a whole bunch of homework left over to do. The process that I like to use when multiplying mixed numbers is to change the mixed numbers into improper fractions. Then I like to reduce diagonally, and then I like to multiply straight across and then look to see if I can reduce again or if I have to change it back to a mixed number. So I'm going to start with number 7. So I'm going to start with number 7. This is what I like to do first. The first thing I do is I change these mixed numbers into improper fractions. And I do that by multiplying the whole number with the denominator. Multiply the whole number with the denominator. Take that answer and add the numerator. So that's 5 times 2, which is 10, plus 1 is 11. And you keep that same denominator. I just changed that mixed number into an improper fraction. Same thing with this one. Oh, is this one a mixed number? No, it's not. So I'm just going to bring it back down the way that I see it. So this is where I am now. And then I'm going to highlight diagonally to see if there is anything that I can reduce. Remember, when you're reducing before you multiply, it has to be done diagonally, not up and down. When you're reducing before you actually multiply your answers, you're going to have to do it diagonally. So you can reduce this way and you can reduce this way, okay? So if I try to reduce this way, will 2 and 3 reduce, or is there a least common factor for 2 and 3? Basically, I'm asking you, if I had this as a fraction, can I reduce that? No, you cannot, okay? So that is not going to reduce. So let's look the other way. If it doesn't reduce, keep it the same. You have 11 and 11, so basically you're looking at this. Will 11 over 11 reduce? It does, okay? 11 will go into itself one time. 11 will go to itself one time. So this is actually going to be reduced down to ones, okay? So I'm going to now change these into 1. 11 will go into itself one time. 11 will go into itself one time. Now I can multiply straight across. 1 times 3, 3. 2 times 1, 2. Can you leave your final answer like this? Of course not. It's top heavy, which means it's improper. So I need to change it back into a mixed number. I do that by dividing the bottom number into the top number. How many times will 2 go into 3? 2 will go into 3. Basically, I'm asking you this. One time. Multiply those two and then subtract. So 2 will go into 3 one time. Your remainder is your new numerator, and you keep the same denominator. This is your final answer for number 7, okay? So make sure you have that down. I'm now going to move on to number 8. So for number 8, remember, first step, change them into improper fractions. 3 times 5. Then add that to the top number. 3 times 5 is 15, plus 1, 16, keeping the same bottom number. Now, same thing over here, 12 times 2. 12 times 2 is 24, plus 1, remember, multiplying, add, is 25, keeping that same bottom number. I'm now going to highlight diagonally to see if there are factors that I can reduce. Let me first take a look at 2 and 16. So basically, I'm looking at this to see if it will reduce, okay? I'm going to use a multiplication chart for this one, because if you're not familiar with factors, you can use a multiplication chart to figure out what number will go into 2 and 16 that will help you reduce this fraction. So if I look at my multiplication chart right here, this is the best way that you can figure this out, okay? Go into each column except column number 1. Can't get that to stay. There we go. You go into each column except don't use column number 1. Don't use this column. Well, all the other ones. And you're looking for a row that has 2 and 16. There's one. Check other even number rows, okay? Because as you know, 2 and 16 are even numbers. So there might be even a better number that'll fit with 2 and 16. Do I have a 2 and 16 in this row? No. Do I have a 2 and a 16 in this row? I have a 16, but no 2. Do I have a 2 and 16 in this row? No. Do I have a 2 and 16 in this row? No. If you notice, you're no longer going to have 2. So this has got to be the only answer that's for me. It's a good way to check, especially when using even numbers. So now all you have to do is go straight up. Your new numbers are going to be 1 and 8. So you have 1 and 8. So you should look like this. Bring this back up, okay? 2 will go into 16. I have to change that 2, change into a 1. This change into an 8. It is an easy way to reduce your fractions and without having to know factors, and just by using a multiplication chart, okay? So now that that direction is done, let's take a look at this direction. I have 5 and a 25. Basically, can this reduce? Okay? Again, if you don't know your factors and you need to use a multiplication chart, that's okay. If you do know your factors, you're probably going to realize that this is going to be 1 and this will be a 5. So it should come out to 1/5. But let's pretend you didn't know how to do that. So I'm going to go back and use the multiplication chart. Remember, you're looking for those numbers again, 5 over 25. Okay? So if I go and look at my 5, and I'm looking for a 25. So I'm looking for a 5 and a 25, okay? So looking for a 5 and a 25 in the same row. Remember, can't use 1, so let me go down. There is no 5 in this row, so I can't use that. There is no 5 in this row, I can't use that. There is no 5 in this row, can't use that. Oh, I found my first 5. Is there a 25? Yes, there is, okay? Quick check a couple of other rows just to be sure. No 5s, no 5s, and if you notice, you're not going to get 5 anymore, so you know that this is the last row that has a 5 and a 25, okay? So my divisor is going to be 5, but my answer, all I have to do is go straight up. I have a 1 and I have a 5th, so this is going to be 1/5. Let's take that back into our problem. So 1, 5. Okay, now that you've reduced diagonally, we can multiply straight across. 8 times 5 is 40. 1 times 1 is 1. And you should know that any fraction that has a 1 on the bottom is just going to be that whole number. So the answer is 40. So for number 8, the answer is 40. Sorry for the messed up handwriting. It is very hard to write with a mouse. Okay? So let me go ahead and do number 9. All right, so we're now going to do number 9. I have this mixed number. I'm going to change into an improper fraction. Remember, by multiplying the whole number in a denominator and then add the numerator. 5 times 3 is 15. Plus 2, 17. Keeping the same bottom number. Now I have your 8 times 4. 8 times 4, I don't really know. 32. Remember, I do not have my facts memorized as part of my learning disability. 8 times 4, yeah, 32. Okay, so I'm going to take that 32, add 1, I have 33, and then 4. Okay, so now I'm going to highlight diagonally this way and this way. I have a 4 and a 17, okay? Let me start with these. I have 4 and a 17. So basically I'm wondering if this is going to reduce any farther. I can already look at it and tell that it's not, typically because I have an even number and an odd number. So I think it might be very much already completed, but if you're not sure, you can always just check. You're looking for 4 and 17. Remember, without using a 1 column, but then you have a 4, no 17. No 4. 4, no 17. No 4. No 4. No 4. You start seeing that, that's not going to work, is it? You can't find a row that has a 4 and a 17 in it. So that will give you a pretty good indication that this is reduced as far as it will go. So these I'm going to leave alone. Now, 3 and 33. If you know your 11s, you know that you can reduce this, okay? So if you don't know, again, look for a 3 and a 33 in the multiplication chart, okay? So if I look for the 3 and the 33 in my multiplication chart, let's see what I can get. All right, so remember, you're not using the 1s columns, but I'm looking for a 3 and a 33, okay? There's no 3 here. Here's a 3. Here's a 33. Let's check a few other rows just in case. There's no 3. And if you notice, there's no 3 for the remainder of this chart. So this is my only option. So my answer is I'm going to divide both of those numbers by 3. Now if I do that, 3 will go into 3 1 time. 3 goes into 33 11 times. Okay? So basically I reduced that 3 and 33 to, this thing always gets away, 1 over 11. So that's what I can change it to, okay? So now I know that I can change this to 1. Make a different color, sorry for the sloppiness, and 11. And this makes multiplying a lot easier. If I remember, or if you don't know, 17 times 11, 17 times 11, did it right? 187. Wow, that's a bad 8. Let me erase that and try that again. 187. 1 times 4 is 4. Okay? So remember, you now need to change this into a mixed number because it's top heavy. So basically 4 will go into the 187. If you do this completely all the way, 4 will go into 187 46 times. And there will be 3 left over, keeping the same bottom number. That's a 4. So your complete answer for this one is 46 and 3/4. All right, I'm going to do a few more. Let's see. Let's go with number 10. Okay, so number 10. This is what I have. Change these into improper. 7 times 7. Again, I do not have my facts memorized. It says your math teacher. Part of my learning disability, but because I have a learning disability now, doesn't mean I can't do it if I have the right accommodations. I have a disability that will not allow me to memorize facts very well. So I do not know what 7 times 7 is, so I gotta look at my chart. 7 times 7, okay, 49. And you guys know that in class all the time. I ask you what the multiplication facts are all the time. So this is 49 plus 2. 49, 50, 51, right? 2 times 6 is 6. I do know that one. Plus 1 is 7. And remember, keep the same bottom number. So here is where we are. Okay? Highlight diagonally to see if there's anything you can reduce. Okay? A 7 and a 7. Remember, a number will always go into itself 1 time. 7 will go to 7 1 time. 7 will go into 7 1 time. Can is 3 and 51 be reduced? Let's see. You don't know? Take a look at the chart, right? So if I take a look at the chart, remember I am looking for a 3 and a 51. Okay? Remember, don't use the 1 columns. There's no 3 here. There's a 3 here. Oh, it is there. And a 51. There's no 3 here. No 3 here. No 3 here. And if you can tell, there's no 3 in the rest of them. So this has to be the answer. I have a 1. I have a 17. So 3 and 51 is really going to be a 1. Because 3 will go into the 3 1 time. 3 will go into 51 17 times. So 1 17th. So I'm going to take that answer and bring it back over here. 1, 17. Now I can simply multiply straight across. 17 times 1 is 17. 1 times 1 is 1. Remember, any number over top of 1 equals whatever that numerator is. My answer for number 10 is 17. Moving on to number 11. Don't forget, you can pause anytime you want. Rewind, do what you need to do in order to learn these concepts. If you know what you're doing and you just want to make sure you get your answers correct, that's fine. Fast forward till I get to the answers. I'm cool with that. But just remember, you can't fast forward on a test, okay? So just make sure you understand these concepts. If not, please be aware, I'm always available for lunch except on Tuesdays, and I'm also available after school a lot of days too. Just let me know. All right, changing to an improper fraction. 1 times 2 is 2, plus 1 is 3. Keep the same bottom number. 3 times 5 is 15, plus 1 is 16. Keep the same bottom number. I'm going to diagonally reduce. Let me first take a look at the 3 and the 5. Okay, I know 3 and 5 are not going to reduce, so I'm not even going to go to the multiplication chart. If you need to, go to the multiplication chart. You will eventually find out that 3 and 5 are not going to reduce. That's as small as they're going to get. But 2 and 16 will reduce. I already know what it is, but I'm going to use the multiplication chart just so that you understand how it is too, how you can use this chart and give you, additional practice with that. Okay, so again, the numbers I'm looking for, which I already forgot. All right, 2 and 16, got it. So I'm looking for 2 and 16. Okay, so remember, don't use the ones. Here's a 2, here's a 16. Okay, look to see if you can find 2 and 16 again, because they're even numbers. No 2, no 2, no 2. And look at that. You're not going to run into 2 anymore. So you know this is going to be the best answer. 2 will go into itself 1 time. 2 goes into 16 8 times. Take that answer over. 1, 18. Or excuse me, 8. Now multiply straight across. 3 times 8, 24. I got a feeling I do this wrong. And then it's almost not right. 2, 18. Oh, whoops. 2, 18 was the 9. Excuse me, guys. I'm going to have to go back and do that one. I messed up something. I don't remember what I did. Okay. Change it to improper. 1 times 2 is 2. Plus 1 is 3. 3 over 2. Okay? 3 times 5 is 15. Plus 1. That would be 16. And then 5. And we realize that this is not going to reduce. But these will. So we have 2 and a 16 using the chart. Remember, don't use one column. 2, 16. 1 over 8. That's what I was looking for. Okay, so go back with 1 over 8. 1, 8. There we go. 3 times 8 is 24. And then we have 5. Oh, I was on the right track. And then this will change into an improper. 5 goes into 24 4 times. 4 left over, keeping the same bottom number. There it is, number 11. 4 and 5/5. All right, number 12. Okay, so with number 12, guess what? With number, whoops, let me put that back where I need it. Number 12 This one is not a mixed number, so I don't have to change anything. So I'm just going to bring this number right back down, okay? So I have 2, and, oh, wait a minute, this one isn't a mixed number either. So I don't have to change any of these, okay? Because mixed numbers, you change to improper. If they're not mixed numbers and they're regular fractions, just go ahead and do the diagonally reducing type of thing, okay? Here we go. So now I am going to look to see if I can reduce 3 and 21 by looking at that multiplication chart, okay? So bring the multiplication chart back up. This thing gets in the way. And I'm looking for a 3 and a 21. So remember, don't use the 1 column. Look for a 3. There's no 3 in here. There's a 3 in here. A 21 in here. And if you're not sure, just check a few more columns. There's no 3. There's no 3. There's no 3. And you can tell there's no 3, so this has to be the answer. And then go straight up. Because if you divide both the numbers by 3, this is what you will get. 3 will go into itself 1 time. 3 goes into 21 7 times. So my answer there will be 1 over 7. And then you're going to take that 1 over 7 and bring it right back into your problem, like this. 1, 7. So let's take a look at this one diagonally. So now I have 2 and 24. Can these reduce? Find out by using your multiplication chart, okay? So if you have your multiplication chart in front of you, here we go. Let me clear off these. Remember, I'm looking for, that always pops it away. So I'm looking for a 2 and a 24, okay? A 2, a 24. So what I'm going to do is look for the row that has a 2 and a 24. But remember, never use the 1 column. Always start with 2. If I look at the 2 columns, I do have a 2 right here. And I also have a 24. Try a few more column rows, especially even numbers. There's no 2 here, so that's not it. There's no 2 in this row. There's no 2 in this row. And if you realize it, you're no longer going to hit 2's. So this is your only answer. So 2 and 24 will be reduced by 2. 2 will go in itself 1 time. 2 goes into 24 12 times. So I just reduced this to 1 over 12. So I'm going to take that 1 over 12 and place it into my answer over here. So now I have 1, 12, meaning I now can just multiply straight across. 1 times 7 is 7. 1 times 12, 12. Final answer. I hope this helps out. So this means I actually did 3 rows of homework. The first row was done in class, and I just did row 7 and the row with 10. So, okay guys, the rest you are on your own. Good luck to you, and I hope this has helped out.